Hello, CSC120. My name is Keyvan Shahrdar. This chapter deals with repetition structures, chapter 8. We're going to talk about some objectives, which is while loops and for loops, and also sentinels for while loops. In a while loop, initialization assigns a starting value to a count variable. Then you have a condition, which is a Boolean expression that executes a statement in the body of the loop while the condition is true. You're going to have an increment and a decrement. An increment increases the value of the count variable by a specified amount. A decrement decreases the value of a count variable by a specified amount. So this is a while loop generic flow chart. So obviously you have start, you have the initialized count variable, then you have the Boolean expression, and this is what is going to be used to determine whether it's true or not. If it's true, it goes through the loop. You'll have a statement, and then you'll have an increment or a decrement. So you could increment a value, and then it goes through the loop. And then if that Boolean expression ever is false, then it steps outside of the loop. This is how it would look in pseudocode. So you have your initialization, your while condition do, statement, and increment. So let's say if you want to print out the numbers from 1 to 3. So you're going to say count equals 1. While count is less than or equal to 3, do print count. So as long as the count is less than or equal to 3, it's going to go through this loop. Each time it goes through the loop, the count increments by 1. So once it reaches 4, it will no longer go through the loop anymore. And this is how the flowchart looks. So you have your count. It checks to see if the count is less than or equal to 3. If it's true that the count is less than or equal to 3, then it goes through the loop. If not, it stops. So one of the things with this loops is you have what is called code tracing, which allows you to see how the variables are doing inside of the loop. So, for this example, we could see that when count equals 1, the output equals 1. When count equals 2, the output equals 2. Count equals 3, the output equals 3. When the count equals 4, well, there's no output, right? So there's no print count because it's outside of the loop. And here we have a flowchart with a trace table. If you could see here, you have your iteration number. So here your start is your first iteration where it starts, and then it goes to A and B. Those are the boxes. So A is the start, B is count equals 1, it increments by 1. C checks to see the Boolean, if it's true or not. If it's true, it goes through the loop and it goes D and E. So it will continue to do C, D, E. As you can see, C, D, E, C, D, E for every iteration. So first iteration, it does C, D, E. Second iteration, C, D, E. Third iteration, C, D, E. And fourth iteration, okay, because there is a 4, because count equals count plus 1. That means it tries to go through it a fourth time, and then that time it's going to say no, the count is too high, it goes to stop. And you could see how everything is sort of staggered. It's not in one line. That's what you do through the trace table. Here's your Python code and output. So this is how it would look in Python when you program. So you obviously do count equals 1 while count is less than or equal to 3, colon, print count, and count equals count plus 1. That's your increment. So a good self-check is to create the pseudocode flowchart and Python code to calculate and print squares of numbers from 1 through 4 inclusively. Show the trace table and the final output from the program to the screen. So this is the pseudocode, num equals 1, while num is less than or equal to 4. Do square equal num times num, print square, and then you do the increment, which is num equals num plus 1. this is how the flowchart would look. So it's similar to what the pseudocode looks like, except you have it in your flowchart form. So we instantiate num to equal 1. If num is less than or equal to 4, then you calculate what the square is, you print the square, and you increment num. Once num is equal to 5, it no longer goes through the loop. And this is the pseudocode for it, which num equals 1 while num is less than or equal to 4. Square equals num times num, print square, num equals num plus 1. And this is how the trace table would look. So you have A, and then you have B, which is part of the first iteration because it's incrementing num. Then it starts at C, which is num is less than or equal to 4, and then D, which is the square, and then E to print, F to increment, and it starts back at C. So you see how each increment, how it is in each increment here. They go C, D, E, F. So the increments are C, D, E, F. And then on the fifth iteration, it checks to see if the Boolean is true, but it's not true, it's false. So therefore it goes to G, which is stop. Calculate and print average of scores. An average is calculated by dividing the sum up by the count. Note that a score of 0 is disregarded and ends the loop. So the flowchart here will get the score. If the score is not equal to 0, then do the loop. So counter equals counter plus 1, sum equals sum plus score, get score, and it keeps iterating through there until the score equals 0. Once it equals 0, it gets the average, and it prints the average. This is your pseudocode. So you see how you have a counter, and then you have the sum, and you get the score as well. And while the score is not equal to 0, counter equals counter plus 1, sum equals sum plus score, and get the score. And then you get the score. You ask for the score again in order to check to see if the score is not equal to 0. And then once the score is not equal to 0, it does the average and it prints the average, calculates the average. And this is how your Python would look like. So the counter equals 0, sum equals 0.0. So you see it's a float number. Score equals input enter score. So that's how you're inputting the score. And while the score is not equal to 0, it increments the counter. The sum equals the sum plus the score, and it has to enter the score again. And that's your average equals sum divided by counter. And this is how the trace table would look. So you see how it's staggered, how you have every single box here, and then the increments are E, F, G, H. As you could see, E, F, G, H are the increments. Then after this equals false, then it calculates the average, and the average equals 82.5. That's what the output would look like. For loops, they combine features of a while loop in a concise format. So you have to have your initialization, a condition, and an increment or decrement. So you do for, initialization, condition, and increment. And then you run your statement once you're in there, inside the loop. And this is how the for loop flowchart looks like. So you initialize, you get your initialization like I equals 0, the condition I is less than 4, I is less than or equal to 4, and the increment is 1. And then you perform whatever you want to perform in the statement. So here, for example, we're saying count equals 1, count is less than or equal to 3, count equals count plus 1, print count. As long as the count is less than or equal to 3, it's going to print the count. Once the count is greater than 3, or count equals 4, it stops. Here's your pseudocode, and here is the trace table, as you could see. And this is how it would look in Python. So you use range. Here it's 1 comma 4, so it means it goes up to 4, but in Python it's a less than here, so means that count is less than 4. Also, the increment is right after 4, so you could do comma 1, it would be the same thing. If you wanted to have a different increment, you would put it there. And here's to calculate the square number and to print the square with a for loop. And again, you see it's going to go from 1 to 3. So if num is less than or equal to 4, so it has to for 1, 2, 3, 4. So your for loop is going to be to 5. Remember, because your count number is going to be less than 5, which would be equal to less than or equal to 4. So that's what it has to be, a 5. And here, to print out the even numbers, so or the odd numbers, so you are starting a number at 1. As long as the num is less than or equal to 30, num equals num plus 2. So you are putting those numbers in plus the num, the product times the num. So the product equals 1. So 1 times 2, right, or 1 times 3, and then 1 times 4, 1 times 3, and then plus 2, 5, etc. And this is how your pseudocode would look, and this is how your output would look. And you could see here it is the output is coming out product equals product plus num. And so here it's incrementing each and every single time for your output. A sentinel in a while loop. So a sentinel is a true or false statement in the while loop. It's not, for example, we've been doing count is less than or equal to 3. So we're checking to see if that's true. But what if you put something in there that is either true or false? And that's what the sentinel will do. So here's, for example, is stating that more is equal to true. So while more is true, do this. And once more equals false, do not do that loop anymore. And this is your Python for the pseudocode that was just entered, and this is how that would look. You could see more equals false if you hit 3, so that would make you exit the loop. If not, you stay in the loop. If you enter an option from 1 to 3, they'll say you selected 1 or you selected 2. They'll keep going until you select 3. Once you select 3, you exit the loop. So how would you replace a Boolean more with a Boolean expression? So you would do something like options not equal to 3, or options less than 3, or options greater than 3. And this is how it would look. Do while loops are used to check the Boolean condition at the end of the loop. So you do something and then you check the condition, you make the statements and then you check the condition at the end of the loop. And this is how that would look. You do the statements and the Boolean. If it's true, you go ahead and keep going through the loop. If not, you stop. Here is you get a value for a positive number. If the value is less than 0, do print you entered a negative number. And then it's telling you to enter a positive number, get the value. So it keeps doing this until you enter a positive value. For the do, you would enter the positive value. If value is less than 0, then you print this while the value is less than 0. That's how you do the do while loop. And this is how it would look like in Python. So you enter the value and then you do while value is less than 0. and you enter what you want to go inside of that loop. You have infinite loops. If you just say while true, print hello, that's just going to run all the time without stopping. In conclusion, while loops are useful when you want to complete repetitive tasks. For loops condense three key elements of while loops in a concise format. Sentinels are used in while loops to replace a variable with a Boolean expression. Do while loops allow the loop code to execute before the loop's Boolean expression is checked. Infinite loops result when the Boolean expression of a loop does not change to false. You could test your knowledge. There are 6 exercises at the end of the chapter to apply your skills you learned. To show that you understand the material presented in the chapter, complete the Chapter 8 quiz at psfpp@go@rich.com. Thanks for watching. Hope you learned something. And remember, you could always contact me by email, ksHahrdar or keyvan.shahrdar@lsus.edu. Or you could call me or text me at 318-453-8082. Thank you.